big, so not very much compared to the radius of the Earth, which is about 6,300 kilometers, but still these small changes can and do have effects on any orbiting bodies around the Earth. Now, I talked a lot about how different motions in the solar system, and what's the importance of these motions. And I would argue that knowing or being able to predict astronomical events is not only important, but it's also very practical. So one example would be, well, not that hard in terms of what mankind can do, but if you can predict the seasons, then you know when to plant your crops and when to harvest and when the river might flood, and that kind of thing. Furthermore, I think a lot of astronomy and being able to predict when things are going to happen was inspired by navigation. So this is a lithograph of Columbus, and you can see his sailors are, they're wringing their garments and gnashing their teeth because they aren't sure that they're going to find land or not. And being able to navigate on the vast oceans of the Earth, and to know in the morning whether you're going to be in Peaceful Bay Cove or at Shipwreck Rock is critically important, and it's a life or death thing. And furthermore, economy is important in terms of being able to predict astronomical events. So it's one thing, or it's a good thing, I guess, to have 8 volumes of tables that you can use in order to predict or figure out where you are on the Earth. But it's even better if you can use one simple instrument and a stopwatch in order to figure out where you are. So economy, or making the mathematics compact, is also an important thing. Oh, and being able to predict eclipses. And so this is maybe not important, but a side story is, this is another lithograph of Columbus. And in 1504, he and his crew were stranded off the coast of Jamaica. And they were there for quite a while doing repairs to their ship. And at first the islanders were very welcoming of them, but then, sailors do what sailors do, and they decided that they weren't going to be very welcoming anymore, and they cut them off as far as with food and supplies. And Columbus just happened to have a book with him that written by a German fellow that predicted that there would be an eclipse that night. And he wasn't sure that the eclipse would happen that night or not, because it was predicted for what time it would occur in Germany. But he took a chance, and he called the leader, and he said, look, if you don't help us, the gods are going to be angry, or I'm going to be angry, and the moon is going to disappear. And sure enough, his prediction was right, and the moon did disappear, and they recanted and changed their minds and decided to help him for a little bit longer. So I guess being able to do astronomical predictions could be I don't know, it makes you seem like a god, or godlike, right? And I still kind of feel that way, that if you're able to do mathematics, people look at you like you're a magician, which is also great. Furthermore, more into modern times, we can use astronomical predictions to predict other things, like climate change. So, for example, the Milankovitch cycles are cycles that predict stages of when there'll be mass ice ages, or I don't know what the other term is, hot flashes of the Earth or something. And this depends on a whole bunch of things. But for example, the precession of the Earth, or the Earth's axis. So the Earth's axis, its rotation axis actually precesses over a period of time. The eccentricity of the Earth's orbit changes slightly over a long period of time as well. And these effects can add up to mean that the Earth is closer or further from the sun at different times. And if that's the case, then we can predict when we'll have particularly hot periods of climate and particularly cold periods of climate, which also might be useful. Furthermore, so we think about sailors on the Earth, but what about sailors in space being able to find things or to navigate through the stars? And certainly being able to predict where things are going to be is important for those types of sailors, like astronauts trying to get to the moon, or, for example, the near-Earth asteroid mission. So this mission, I think it arrived in 2001 and photographed up close an asteroid called Eros. Eros is something like 280 million miles away. No, wait, 218 billion miles away. And we were able to find it to approach it within 750 miles to find an object that's 20 miles long and 8 miles wide, so it looks like a big fat banana. And that, to me, wow, that's just amazing, and speaks to the predictive power of dynamics and the triumphs that we've had with using it. But we want to know, or I'm at least interested to know, is the solar system stable? I mean, we have these cycles that we can predict with accuracy. But is the solar system, well, first of all, has it always been that way, and is it going to continue to be that way in the future? It might be something to take a look at. And this is a photo of